Hey Sauce, Surrey here. Today we'll be talking about cars, why cars crash, and why pushing someone can make them move or fall down. Momentum can be understood as a quantitative value of mass in motion, or as a representation of how much stuff and how fast that stuff is moving.
So what is this concrete definition of momentum?
Momentum can be defined as the product of mass and velocity. So if two objects have the same mass, the one with a greater velocity has a greater momentum.
Can I see an example of momentum in action?
Let's say D-Sauce is driving a car of mass 314 kilograms. And this is moving at 100 meters per second to the right. What is the momentum of this car?
So I'll just apply the formula. P is equal to mv. P is equal to 314 times 100. 314 joules. Yay.
No!
But I got my multiplication correct.
But that's not the problem. The problem is your units.
It's not joules?
No, it's kilograms meters per second.
Oh.
Yes, sir.
Yo, what about me? I need to know more about momentum.
So remember when you crashed the car into the gate?
That was an example of a collision.
There are two types of collisions, elastic and inelastic.
In an elastic collision, energy is conserved, but in an inelastic collision, energy is not conserved. However, in both types of collisions, momentum is conserved.
Okay, so who cares?
So basically, elastic collisions can never physically happen.
But they can serve as really good approximations for what happened with elastic objects.
So, when two objects collide in an elastic collision, energy and momentum are both conserved.
So we can arrive at these equations.
I have an example.
So let's say two blocks of equal masses collide on a very icy surface, and the initial velocity of the first object is at 5 meters per second, and the second block is at rest. What are the final velocities of both objects, given that they don't stick to one another?
How am I supposed to solve this problem if I don't know the masses of the blocks? This is a bad problem.
Well, actually, you don't need to know the masses of the blocks individually. Because we know they're equal, m1v1 plus m2v2 equals m1v1 prime plus m2v2 prime. Can be simplified by canceling all the m's. So we just get v1 plus v2 equals v1 prime plus v2 prime. Also, since we know that this is an elastic collision, because it's explicitly stated, the kinetic energy is conserved. So half m1v1 square plus half m2v2 square equals half m1v1 prime square plus half m2v2 prime square. Canceling out the m's and the halves, we just get v1 square plus v2 square equals v1 prime square plus v2 prime square. Now we have a system of equations, and if we solve this, we'll find that eventually we get down to 0 equals 2 v1 prime v2 prime. Now, this implies that either v1 prime or v2 prime is equal to 0. But in order for that to be the case, there still needs to be a change in the individual velocities. So we know that v1 prime must be 0 since initially it was 5. Therefore, v2 prime by the first equation is equal to 5 meters per second. So in the end, the second block is moving at 5 meters per second and the first is still.
If this collision was inelastic, the energy would not be conserved due to deformation, heat, and sound. Therefore, we cannot assume that the kinetic energy will be constant, and we cannot perform these calculations.
Since momentum is always conserved, what this really teaches us is that through the infinitely many collisions in life, we can always keep going. And as always, thanks for watching. Yep.